Hey everybody, I just wanted to thank you all for hanging in there with us during this whole thing going on with the virus spreading and just working hard with us now that we're starting to get in more into like actual learning and teaching where we're doing some grading and just hang in there with us. I know it's going to be a little more difficult than if we were in school. Keep working with us, communicating with us. We love when you communicate with us. Give me feedback on the videos if you need me to do something differently. Don't be afraid to reach out to me or Mrs. Stofflet and ask questions. It doesn't always have to be about math, just about the pacing of things. Anything you need really from us, just let us know. We'll be there for you. We'll help you through everything that's going on. Don't be afraid to talk to us in any way. Email, sending us a recording if you want. Anything you really want to help you communicate what you need to us so we can help you. We're here to help. We're ready to do anything we can to help you through all this. So, going off of that, today we're going to be learning about rotations, and this is a little more difficult than the last two lessons we've had. So just stick with me in this. It's going to be a little more difficult than what we've done. A rotation is a transformation again. So again, it's a transformation in which a figure is rotated or turned, just like it sounds like. It's a figure is rotated or turned about a fixed point. And they will tell you the fixed point in these problems so you'll know where it's rotating around. And it doesn't always have to be in the same position with this shape. The center of rotation is that fixed point. So that center of rotation is the fixed point that they just talked about. And that is it for your vocab in this lesson. This lesson may not seem long, but it will be difficult. So just hang in there with me. So rotation is a figure is rotated or turned around a fixed point, which is called your center of rotation. That's the only new vocab we have. All right, let's go to the example. Let's work through this together. So a triangle, LMN with vertices L, 5, 4. So here's our L right here. 1, 2, 3, 4, 5, and up 1, 2, 3, 4. That's the L. M is 5, 7. 5 over 1, 2, 3, 4, 5, 6, 7. And my N is 8, 7. 6, 7, 8, and it's up 7. So this is my original shape right here. Now we're trying to find, he wants us to rotate this triangle, which represents a desk in Jackson's bedroom. He wants us to rotate the desk counterclockwise. So counterclockwise, that means if we're looking at a clock, let's say I got a clock over here. The hands of the clock move this way. Counterclockwise is the opposite of that. So we're going this way, in this direction. So we're rotating it that way, counterclockwise. Opposite the way the hands on a clock move. If it's clockwise, you go the way the hands move. Counterclockwise, the opposite. So we're going the opposite way the hands move on a clock. Graph the figure and its image, then give the coordinates of the vertices for L, M, N prime. So we're moving this 180 degrees counterclockwise. 180 degrees is a half circle. So notice their circle, their little line that they drew to help us. It's half of a circle. They're moving this triangle halfway around in a circle. So their center of rotation is where L is in this one. They didn't explicitly say that, but they're just rotating the desk, so we know that it's on this point right here. So their center of rotation is right here on L, and they're moving every shape. That means since the center of rotation is on a point, that point actually is still going to be there. It's on that point, so that point stays. Everything else moves around that point. So M is going to move the 180 degrees, so we make a trip half a circle around. Notice it makes a straight line across from where it was because it's 180 degrees straight down. And 180 degrees also, we're rotating it, and it's also going to make a straight line from where it was because it's 180 degrees makes a straight line. So that gives us all the points we need. So they graphed and rotated the image, use a protractor. You're not necessarily going to have a protractor, but you can use a protractor to measure an angle of 180 degrees, but we know that 180 degrees makes a straight line. We've talked about that before when we talked about supplementary angles. So straight line for 180 degrees. Repeat step 2 for point N. We did that since L is the point at which element is rotated. It's the same position. I talked about that. So the coordinates of the vertices of L prime, M prime, N prime are 5, 4, because L is in the same position. M is now 5, 1, so we can count that out. 1, 2, 3, 4, 5. And it's up 1. And N is 2, 1. 1, 2, 1. Notice that from these point, the center point, your point of center of rotation, the distance to M, 1, 2, 3, and the distance to N prime, 1, 2, 3, are the same. These are always going to be that way. So N is now 1, 2, 3 points diagonally. So that's not necessarily 3 units, but 3 dots over, 3 dots over. These are always going to be the same distance from the center of rotation. N and N prime will be the same distance. M and M prime will be the same distance. That's important because the pre-image and the image are congruent. They have to have the same distance. They're congruent. It's the same shape. And that will always be true with this being the pre-image and that image. They'll always be congruent, and they will always be the same distance from that rotation, center of rotation. So keep that in mind. Center of rotation, everything is the same distance as its after image. The dots will be the same distance. So that's important to remember. So if you take anything out of this, I want you to take that out of there. And then just remembering 180 is a straight line. We'll go over 90 and 270, some other kind of rotations that we'll be using a lot of in this. Also, we'll learn a little bit more about some things you can do to help you remember them, some shortcuts, some strategies. We'll get there. Just start with this for now. And we're going to move on to a got it. Remember, at any time, you can rewind, go back through, watch again, pause to think about things if it's going too fast. So do whatever you got to do while you're watching the video to help you comprehend the information the best. All right, so we have rectangle ABCD with vertices -7, 4, -7, 1, -2, 1, and -2, 4. And this represents a bed in Jackson's room. So let's start with just putting these points down. And this is also a good time to pause the video and try this got it by yourself, see how you feel about it, and then watch it with me going through it, and we'll see how you did. You can always just go back and try it again if you need to. But at this point, I'm going to start going through it. So, A, we're at -7, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. This is my A. B, we're at -7, 1. 1, 2, 3, 4, 5, 6, 7. Up 1. -7, 1. That's B. My C is -2, 1. 1, 2. Up 1. And my D is -2, 4. So 1, 2, 3, 4. And that is a rectangle. I'm doing my best to make straight lines. They're not perfect, that's okay. And now, graph the figure in its image after a clockwise rotation of 90 degrees about vertex C. So about vertex C, when it says about, we're rotating about, that's telling you that that's going to be your center of rotation. So C is our center of rotation, and C was right here. And D was right here, -2, 4. So C is our center of rotation because it's about vertex C. Clockwise rotation of 90 degrees about vertex C. All right, here's our center of rotation. We're moving everything 90 degrees clockwise. That means if we look back up at our clock up here, our hands are going which way normally? They go this way, to the right. They're moving right and then back up and around. So our figure is going to move in this direction, 90 degrees. 90 degrees is half of that half circle. So it's a quarter of a full circle. And if I were to draw a circle around this point, starting with D, I wouldn't do this every time. It's a little confusing. I wouldn't actually write this even on your paper. but I'm going to be making a circle like this. So 90 degrees is half of this full rotation, or quarter of this full rotation, excuse me. So a quarter of this, if I were to quarter this circle up, my D would be over here. So I'm moving in this direction, that much too. So my D is 1, 2, 3 from the center of rotation, and it's going to be rotated down a quarter, 1, 2, 3, quarter of that circle. That full circle, 90 degrees is a quarter of a full circle. And you'll get more practice with this. This isn't easy stuff. It's going to be difficult. So here is my new D prime. C prime, same position. Don't even have to worry about that one. Now, this is where it gets a little more difficult. A. I would remember that, hey, I'm moving this up. Like I said, it's going to be the same distance from C as it is here. But A prime is also going to be the same distance from D prime as A is from D. So I know I'm rotating this way. So my circle's going to be going way out and around. But if I remember, hey, it was this way now, it's going to be moving up here somewhere. So now it's going to be 1, 2, 3, 4, 5. 2, 3, 4, 5 away from D prime. So we're going up 1, 2, 3, 4, 5. This is where this part rotated. Right up to here. It makes a weird circle around. It's always connected to D. This whole rectangle is just shifting like this. If it shifted all the way past here, it would then be down to here. So, D A prime is now up here. B, we are 1, 2, 3, 4, 5 away from C. If I am making a full circle around, or a quarter of a circle around C, I'm moving up into this area. So I'm going to be up right here. 1, 2, 3, 4, 5. Because this is a right 90 degree angle. We're moving up 90 degrees. So B prime, A prime, D prime, and this is also C prime. My new shape looks just like that. It just rotated up. Imagine a block laying flat on the ground and you rotated it up 90 degrees. That's all that happened right there. You went from this block being right here, here's your point, and you just rotated it up like that. 90 degrees is just that rotation from laying flat to up. So flat to up. If it's 180 degrees, you're rotating to flat and all the way back down underneath. So it'd be more like this. All right, so I know that's a little confusing. It's not easy information to learn. This is going to be a tough lesson. We'll work through it together. We're going to get this. So, moving now, we're going to talk a little bit about rotations around the origin. So a little bit different. We were rotating around the vertex. Now we're talking about rotating around the origin. A rotation is a transformation. We've talked about that. That's just the definition of it. Rotations shown are clockwise rotations about the origin. So these are models for clockwise rotations around the origin. They're giving you an idea of what it looks like. So right here, a 90 degree rotation from your points is going to be 90 degrees. Every single point. So 90 degrees, they come down and they make a 90 degree angle right here. And here's what's going to actually happen to your points. Your X is going to move to your Y position and be negative. So my X value right here is -1. It became your Y position, 1, which is negative. So I'm going to write down this point up here. Let's just look at this point right here. So -1, 1, 2, 3, 4. That's a -1, 4. What this is saying is my X value, -1, is going to move to my Y position. So my X value, -1, is going to be a -1 now. It's just going to be a +1. -1 is a +1. So -1. My Y just moves to the front, to my X position. So my Y was 4. That just moves to my X position. So now I have 4, 1. 1, 2, 3, 4, 1. That's all it is. over 4 up 1. They're taking your y value, moving it to x, and taking your x value and moving it to your y, and doing the opposite. So opposite of -1, +1. Another example would be, let's look at b. -3, 1. So b was -3, 1. The opposite of -3 is 3, and we move that to the y value, and our y value goes to the x value. 1, 3. 1, 1, 2, 3. That's our 90-degree rotation around the origin. And this thing right here, this little symbol, the formula for you, that is the best way, I think, to figure this out, because it can be confusing just looking at this. Your dots, so if I go from here to my origin to here, that's making a 90-degree angle, but that's hard for you to tell. So use these symbols. You're going to want to come back to these to help you through the homework. So x becomes opposite of x, and then is your y. Y becomes your x after the rotation. 180-degree rotation, everything just turns to its negative. This one isn't too bad. So 1, 1 becomes, everything is the opposite, so it becomes -1, -1. And then that is your new A prime. Your C, 1, 4, -1, 4, sorry, -1, 1, 2, 3, 4, is going to be opposite of -1 is 1, opposite of 4 is -4. That is your new C prime. So 1, 1, 2, 3, 4, -4, 1, -4. And then it'll do the same for B. So you just do negative, you do the opposite of everything in your ordered pair. And everything stays in the same position. So it's different than this 90-degree rotation. 180 degrees, everything is just opposite. You don't move them in that one. They're just opposite. 270 is very similar to the 91. So these are going to be confusing. You're going to want to reference these when you're doing your homework. Otherwise, you will get confused. You might even want to write these down on a separate piece of paper to remember. So 270, xy becomes -yx. So A is -1, 1. If my x is now my y, my pair is going to be -1, and my y is now where my x was, and it's opposite of it. So it's -1, -1. -1, -1. And I know that sounds confusing. It's not very easy to explain. It's kind of hard. It's going to be difficult. You're going to have to kind of experiment with it a little bit. You can look at these points and try to see how they changed. But that's going to make a 270-degree rotation to that point around here. So remember, these are what you want right here. Those are your formulas that you're going to be using. So this is my 90-degree one, 180-degree, and 270-degree. I'm going to see. Hopefully this doesn't smear. You want the 90-degree one, the 180, the 270. Those are what you're going to be using. And these figures can be rotated throughout the origin. That's just for when it rotates around the origin. Not when it's on a vertex. Only the origin. So these are for only formulas for rotations around origin only. That's important. It will not work with just a rotation around one of your vertexes. Only around this origin. The origin is where your x-axis, your x and y-axis points connect. Your 0, 0 dot. So let's try an example. We're going to work through this. It's going to be difficult at first, but we'll figure it out. Remember to reference back to these formulas up here. So triangle DEF has vertices -4, 4 for D. My E is -1, 2, and F is negative 3, 1. Graph the figure and its image after a clockwise rotation of 90 degrees about the origin. About the origin. That means that is our center of rotation. That's what it's rotating around, the origin. So we can use these formulas that we have, and it's doing a 90 degrees clockwise. So 90 degree clockwise rotation. This is a clockwise rotation of 90 degrees. So we are using this formula right here. XY to Y negative X. Your Y goes from this position in your ordered pair right to here. So let's look at what we got. They started just graphing out their points, D, E, and F. So D was negative 4, 1, 2, 3, 4, negative, up 4, 1, 2, 3, 4. That's where our D is. Our F is negative 3, 1, so they went 1, 2, 3, and up 1. Negative 3, 1. Negative 1, 1, 2 for E. And they started with their E prime. So E was negative 1, 2. If we look up at our formula, negative 1, 2, using this, our X is now the opposite of what it was. So negative 1 is now opposite of negative 1, which is 1. And it goes to the back of our parentheses. So instead of being where the X value usually is, it is now on the end of it. So 1 is right there now. My Y was 2 for E. So now that Y is now just at the front of my parentheses. So 2, instead of being at the back, is now at the front, giving us 2, 1. And that is exactly where they put this E. 1, 2, up 1. And that makes a 90 degree right there. All right. So we're doing the same step for D and F. Let's look at what we got for D. So D, we have negative 4, 4. Using our formula up here, negative 4 is our X. So negative 4 is now going to be at the end of the parentheses, and it's going to be opposite. So opposite of negative 4 is just 4. So it's going to be 4 at the end. Now, our Y value, which is 4, is now just going to move to the front of the parentheses. Y is now in that position. So we're going to have 4, 4. Let's look where they had their D. Their D is now at 1, 2, 3, 4. 1, 2, 3, 4. Right where we had it. Our F was negative 3, 1. So I'm going to write that down right here. Negative 3, 1. This is our F. I'm going to put this as a D and rotate. This was E. All right. So our F was negative 3, 1. Let's use our formula. Negative 3 is X, Y is 1. So the opposite of X, because there's a negative there, it's telling us it's the opposite. The opposite of X is just 3, because negative 3's opposite is just 3. And now we're going to move that to the end of the parentheses. So 3. My Y value was 1, and we're going to put that in the front of the parentheses. So 1, 3. This is my F prime now. This is my F. This is my D prime now. So F prime is at 1, 1, 2, 3. Notice it's the same triangle. Everything is the same distance away. So D prime and F prime are the same distance as D and F. If that is not the case when you do this, something is wrong. Go back and try to see what happened, or email a question, get it figured out somehow. However you can. Just notice this should still be the same distance. It should still look like the same shape even though it's rotated differently. So everything should look the same. If your shape looks totally different, something bad happened, it's something wrong. It does happen sometimes where you mess up that way. It happens to everybody. Just notice it's going to be the exact same shape. That's just rotated. So that's a 90 degree one. All right. Now we have a got it. Try this got it on your own. Remember to reference back these formulas. These formulas right here. These are going to help you. You're going to need these. So reference back to these to help you with this. All right, pause the video, try the got it, and then resume it when you're ready to go over it with me. All right. So I'm going to give you a little time to try that. Let me know when you're ready. All right. So let's start with just graphing our points. MNPQ has vertices M at 2, 5. 1, 2, 1, 2, 3, 4, 5. That is my M. N is at 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. P 6, 1. 1, 2, 3, 4, 5, 6, 1. Up. And Q is at 2, 1. 1, 2, 1. So we have a nice quadrilateral here that we're going to be working with. And it wants us to rotate this image counterclockwise 270 degrees. And now we haven't really talked about counterclockwise, so this may be a little confusing. But if I rotated this one counterclockwise, let's look at this image here. If I rotated this counterclockwise 90 degrees, I'd be going this far 90 degrees, right to this point. Negative 90 degrees goes from 360 to 270. So a counterclockwise turn of 270 is really the same as a 90 degree rotation clockwise. So I want to write this down here for you. 270 degrees counter clockwise. I don't like what that is. So here's what I want you to do. 90 degree rotation clockwise. These are all clockwise. So this is clockwise. 180 degree clockwise, clockwise. This is also a 270 degrees counter clockwise. 180 degrees is the same either way. So if I went 180 degrees this way, it's the same as going this way. Both of them are going to end up in the same position. 270 degrees clockwise is the same as 90 degrees counter clockwise. So 90 and 270 are the same if you do counter or to clockwise. So counterclockwise 90 is the same as 270 clockwise. 270 counterclockwise is the same as 90 clockwise. So they change the words up and they use a different number, it's the same. So that's going to be kind of hard to remember. Just do your best with that. But we're going to use that so we don't have to try and think of a new formula or eyeball this up. So we're going to use the same one right here. XY to Y negative X. I'm going to write that down so we can remember that. XY to Y negative X. And we're going to use this to help us with this. 270 counterclockwise. Make sure we're really paying attention to those words. You need to know which direction you're rotating and how much. Those are the things you need to know after you have your points. I kind of highlighted dark. All right. So XY to Y negative X. I'm actually going to make a chart. I think a chart would help you with this. So M, how do I want to do this? My original points, pre-image, and after. Pre and after rotation. That's how I'm going to label it. And so we have M, N, P, and Q. M was 2, 5. Oh, you can't see my chart. All right, there. Now you can see it. So I got 2, 5. I've got 6, 4, and I've got 6, 1, Q, I have 2, 1. My after images, using my, hopefully I can fit this all on here. My little formula, I'm going to put that up here too. So I went from x, y, 2, y, negative x. That's going to be the new layout. So 2, 5 would become 5 in front. My y goes to the front, so 5 went to the front now. And 2 becomes its opposite and goes to the back. So 2 is now negative 2, and it goes to the back. 4, 6, 4 goes to the front because it was my y. My x goes to the back and becomes its opposite, so 6 becomes negative 6. 1 goes to the front because it was my y. 6 goes to the back because it was my x and becomes negative, so negative 6. 1 goes to the front because it was my y. 2 goes to the back because it was my x and becomes an opposite of 2, which is negative 2. So these are my new points. This is M prime, N prime, P prime, and Q prime. So all we have left is to graph those. So going from here, 1, 2, 3, 4, 5, and down 2. 1, 2. I should label all my points. I don't know why I didn't do that. So this is Q, here's N, and this is P. So M prime is now here. 4, negative 6. Is my new N prime. 1, negative 6 is P prime, and 1, negative 2 is my Q prime. So notice, wow, that was really bad lines, but notice that this is the same shape. And if I went around from Q to Q, my shape went 270 degrees around. And notice that this 90 degrees that we used and this 270 line up right to that same point. That's what I'm trying to say. These 90 and this 270 are the exact same, because this is also going to go 270 around this origin all the way to P. 270 around the origin all the way back to here. We're moving to a different quadrant. So this would also be a 90 degree angle. N will also be a 90 degree angle to that's N. And M would be a 90 degree angle to this M. So, key takeaways from this lesson. I know this was not easy. It was a long lesson. What I want you to remember are these equations that they gave you for 90 degrees, 180, and 270. That's my first key takeaway. I also want you to try and remember 270 counterclockwise is the same as 90 degree clockwise. 270 clockwise is the same as 90 degree counterclockwise. And 180 either way is the same. Because if you know those, then you can apply these equations to both situations. So I want you to take away that. Those are my first two takeaways. My second takeaway that I want you to have is that this 180 degrees is going to make a straight line on a vertex one. And that on a 90 degree one, it's going to be a 90 degree angle. So it'll go from flat to up the position. Also, your center of rotation, the distance from each point to that rotation, center of rotation, is always the same distance, no matter the after image or pre-image. And the pre-image and after image points will all be the same distance apart because it's congruent. So congruent same distance, all that. And I know this is not easy. If you have questions, do not hesitate to ask. I kind of hoping to get some questions because I feel like this is going to be a hard lesson. So I'm hoping to get some questions from people so that I can clarify things if people are confused on points. Let me know what confused you in this lesson, what you need help on. I might even be able to do some reteaching of some things to help you with this. I know this was not an easy lesson. I don't expect you to get it right away because this is quite difficult for anybody, especially if you're learning it for the first time. So don't get frustrated with how this lesson goes. It's not easy. We'll work through it together. So I hope to hear from you. I hope to hear questions because I'm kind of expecting them. So don't hesitate at all to ask questions on this. All right. I should be hearing from you hopefully soon. I will have another lesson posted on Monday, and I will have the problems posted under the assignments like I did for the review. So if you're still having questions on how to figure that out, let me know. Maybe I can make a video on how to access everything if you need it. Just let me know if you want that or not. All right. Bye.